Hi, good morning, and welcome to the ZP Vlog and Podcast. We do this every Sunday at 8 a.m. London time, and it's really just a wrap up on the news that we've put out from ZP this week. So, one of the things that we've discussed this week is um, we do test a lot of chili products. We make a technology called FoodSense. And one of the sort of interesting challenges with a technology like FoodSense is really what we could kind of call the matrix or sample effect. That there's so many ways of, so many sample types. You can have powders, you can have pastes, you can have sauces, you can have the chili berry or the chili fruit itself. So there's so many, let's say, examples or variation there that actually it's the sample preparation, the sample extraction that's the real challenge. And so this week you'll see that we've put a video out with one of our guys in it called Solrun, and there she's running through the idea of how we're doing the extraction of chili powder, for example, there, and we talk about the kind of dilution, etc. So we put a video out this week about our FoodSense technology and how we're then using it to extract things like chili powder. Something else that we put out there this week, it's been a sort of I want to say an eclectic week, but something else that we've put out there is also about impedance spectroscopy. Um, I think impedance spectroscopy is something that people tend to do sort of one, two, three, four experiments. Um, we were doing an impedance experiment this week, and we did essentially 270 experiments in that. And the reason I sort of mention it is because it's an awful lot of experiments. In order to kind of understand the system properly, as I say, we did 270 experiments, and this kind of working at scale when it comes to gathering electrochemical data, especially in the biosensor space, is not super commonly done. And so but at ZP, we do it, and we do it for our clients. So we just put some, a little image out and a little note about that as well. Of course, every Thursday at 8 a.m. London time, we do our webinar specifically for the members of our ZP Developer Zone. And this week we talked about pH monitoring in bandages. We talked about calcium and NO and hydroperoxide monitoring. We talked about detecting the survivability of cells. We talked about entrepreneurialism. We talked about sensor starter kit. We talked about measuring pH and flow. We talked about precision, accuracy, and error in capsaicin measurements. We also talked about problems with glucose measurements in SMBGs, self-monitoring blood glucose. So we did cover a lot of, again, topics this week. And, if you have any technical questions as Zimmer and Peacock, then I would say don't hesitate to reach out to us. We do try to keep a list going of the questions that come in, and we generally are able to sort of respond to these questions basically within the week. So we got, quite a fast turnaround on answering questions in our ZP Developer Zone. We also touched upon then, we sort of also specifically, as I say, delved in on the idea of accuracy and precision in measuring capsaicin. There's if you're talking about measuring things like chili products, there are kind of three ways of that generally happen, which is people use HPLC systems, um, people use taste testing or tasting, I should say, and people use the FoodSense. Now, when they get these HPLC measurements, they're not always doing the HPLC measurement themselves. They're actually sending it out to third parties, and they get a certificate of analysis back, and that's said, okay, well that must be correct. Well, actually, when you dig into the HPLC analysis of things like chilies, you will actually find that different labs may end up giving you different results. So if you send the same let's say same chili or cut up chili to or blended chili to several labs, you actually come back with different results. And if you send the same products to the same lab over time, you'll also find that they come back with different results. Now, I say in the video all the reasons why it's not it's no one's fault, but that is the case. And so when people sort of say, well, I've got this certificate of analysis and you have this different result, sometimes you find the difference in the results is like something like 13%, which I talk about in the video, which you know two different methods, two different times on probably two different samples, and you get a difference of 13%. It's probably acceptable. Other times you may have 35%, and there we talk about how to deal with that kind of offsets, because in the end it comes down to the fact that it doesn't mean that the certificate of analysis in the HPLC sample is absolutely the correct. For the reasons I've listed below, that different labs and even the same lab on different days will give you different results. So I do cover that in quite some depth and talk about accuracy and precision on the channel this week. Something else that was just a little bit of a fun short that we put out there was also detecting iron in liquid samples. So you can have an industrial process, you may have a human health application, but iron appears in lots of solutions, and ZP has a very neat way of low power, low cost way of putting a sample onto a sensor and essentially detecting that iron is there. So we show a little application to do that. So that's something that can be seen on the blog this week. Something else that we talked about this week is we do have quite a nice range of sputtered or vapor deposited gold electrodes. We needed to put a data sheet out there. So this week we put together the data sheet and essentially made it available to people. So if you've got dimensional questions regarding our sputtered gold electrodes, then there's definitely now a data sheet out there, and people can kind of essentially engage in that and have their questions answered regarding our sputtered gold electrodes. And then something else that we put out there just yesterday, it's quite a long video, sort of 20 minutes, but we talk about quality control in biosensor development and biosensor manufacturing. But I think really we're focused on in that video on biosensor manufacturing. We do talk generically about IQC, OQC, IQC, QC, and OQC, incoming quality control, and outgoing quality control. We talk generically about this, but I think the example that's best given is the glucose strip. I mean, the glucose strip, because it's the kind of archetypal glucose or biosensor, I should say. It's probably because it's the most manufactured electrochemical biosensor in the world. And the ideas of where you would do quality control, they sort of come in part from making glucose strips, but they can then be applied to other sensors as well. So we do talk about, that there's electrical testing that can be done during manufacturing. There's profilimetry that can be done during manufacturing. There's visual inspection that can be done during manufacturing. And there's electrochemical functional testing that can happen during manufacturing. So we have all these ways of characterizing electrodes during manufacturing. We do say that really at ZP, what we do that's, we can do electrical testing, we can do profilimetry, we do visual inspection, we do electrochemical functional testing. But it really comes down to the electrochemical functional testing. Everything else is a surrogate for actually doing electrochemical functional testing. If you really want to know how well your electrochemical biosensor is going to work in that particular application, unfortunately you have to electrochemically functionally test it. It will tell you it'll give you the information that electrical connection testing will do. It'll tell you a lot about the visual inspection. It'll tell you a lot from profilimetry. So it sort of contains information that the other three methods that I've listed would also have told you. But it also brings it an extra property, which is it tells you about the electrical resistance between the electrode and the solution under test. And that's just something that the other methods really are not able to do. So it was a 20-minute video. I mean, it's a little long, but I hope people are able to go through it. So if I was to summarize up this week, I used the word eclectic at the beginning, but we have talked about measuring the hotness of chili powders and how we have to deal with these different kinds of matrices. And I hope these are interesting to people because you can see the challenges of doing real world samples. We talked about electrochemical impedance spectroscopy and how, when we're doing those kind of methods, we're really doing it at large scale, 270 experiments, for example. We did talk about our webinar and how we cover all these kind of questions. So if you have a question on ZP, I think most people get their questions answered within 1 week, because we bring them into the webinar that we do every Thursday at 8 a.m. London time. We did talk about precision and accuracy when measuring Scoville heat units. We did talk about detecting dissolved iron. So in that case, we were talking about low-cost sensors, low-power sensors for detecting iron in solution. We put out a new data sheet regarding gold-sputtered electrodes. So I know we have a strong reputation for high-quality screen-printed electrodes, but we also have sputtered electrodes as well. And I suppose that word quality is nicely tied, because actually we then put out a video about contract quality services for biosensor manufacturing, and how ZP can be a consultant or a contractor when determining about IQC, QC, and OQC in the production of biosensors, and including glucose strips. So I'll end it with that. But if you have any questions of ZP, especially technical ones, send them in. They will get responded to in our weekly webinar for biosensor developers. That happens on 8 a.m. London time every Thursday. Okay, so I wish everyone a good week, and we will be doing our webinar on Thursday. Okay, take care. Have a good week. Bye-bye.